Welcome to today's Explainer. We're going to completely shift your perspective on the world's most catastrophic historical events. You know, we so often just wave away these terrible tragedies as acts of nature, right? Well, what if I told you that nature is really only half the story?
Okay, let's dive into this. Are natural disasters purely natural? It's a pretty fundamental question. I mean, every single year, our planet experiences earthquakes, floods, and massive storms. But here's the thing. Some of these hazards pass by with minimal casualties, while others, they kill hundreds of thousands, sometimes even millions of people. Why is there such a staggering difference?
Well, just consider this number for a second. 7.5 million. That is the combined estimated death toll of just the 6 deadliest disasters in recorded history. Honestly, it's a number so large it's kind of impossible to process. And it sets up our central mystery for today. What exactly made these specific historical events so uniquely fatal? Was the ground just shaking that much harder? Was the wind blowing that much faster? Well, actually, not necessarily.
The real answer lies in one word: vulnerability. Simply put, vulnerability is the degree to which a person, a community, or even a structure is susceptible to harm. It turns out that a region's geography, its infrastructure, and its political climate, those are the true deciders of a disaster's death toll. A natural hazard literally only becomes an apocalyptic disaster when it strikes a highly vulnerable population. Let's look at Section 1. Fatal Geographies, when the land betrays its people.
It's a really tragic irony that the very environments that nurture ancient civilizations can suddenly become the deadliest traps. To illustrate this, we're going to compare two incredibly fertile but ultimately fatal landscapes. On one side, you have the Shanxi province in central China. This area is defined by its Los cliffs, which are made of soft, wind-deposited, incredibly nutrient-rich soil. And on the other side, we have the flat, silt-rich islands of the Ganges-Brahmaputra Delta in East Pakistan, which is modern-day Bangladesh. Both of these landscapes were total agricultural gold mines. They naturally attracted massive, very dense farming populations. But because of their highly specific geographic features, they left millions of people with absolutely nowhere to run when a hazard struck.
Take a look at this staggering number: 830,000. That is the estimated death toll of the 1556 Shanxi earthquake. It's actually the deadliest earthquake in recorded history. Remember that soft, lowest soil I just mentioned? Well, for centuries, the local population had carved their traditional homes, called yaodongs, directly into those cliffs. It was brilliant for insulation, but absolutely fatal during a quake. When a massive earthquake hit in the early morning hours, a process called soil liquefaction occurred. Basically, the saturated soil temporarily behaved like a liquid. So the cliffs didn't just crack, they instantly and completely collapsed. Hundreds of thousands of people were buried alive in their beds, with virtually zero possibility of rescue.
Now, what's really interesting about this is how the geography of the Ganges-Brahmaputra Delta set a completely different kind of trap back in 1970. The Bola cyclone pushed a massive storm surge, literally a wall of seawater almost 20 feet high, straight across those flat delta islands. Because those islands were formed by flat silt deposits, there were no hills. There was zero high ground to escape to. That specific geography left 3 million sleeping residents just utterly defenseless against the water.
That total lack of high ground resulted in an estimated 300,000 to 500,000 deaths, which makes it the deadliest tropical storm on record. But, the disaster didn't actually end when the waters receded. The response from the Pakistani government at the time was widely criticized as being slow and severely under-resourced. Looking at the historical record neutrally, we can see that this perceived indifference deeply aggravated existing political tensions between East and West Pakistan. The mishandling of this cyclone actually compounded the crisis, leading to a civil war that eventually resulted in the birth of the independent nation of Bangladesh.
Moving on to Section 2. Crumbling defenses, infrastructure, and politics.
Neglected infrastructure and political instability can take a heavy rainy season and just turn it into a world-ending event for the people living through it. To really understand this, we need to look at China's Yellow River. Historically, it's been called the River of Sorrow. See, the river carries an extraordinarily large amount of silt, which it constantly deposits right onto its own riverbed. Over millennia, this continuous sedimentation actually raised the bottom of the river up to 30 feet above the surrounding plains. Think about that for a second. The river was literally flowing highly elevated, suspended right above the rooftops of nearby farmhouses.
To keep that elevated river contained, farmers and governments built massive earthen walls called dikes. But a whole series of compounding failures led to the totally devastating 1887 and 1931 floods. Both the late Qing dynasty and later the nationalist government were severely weakened by civil wars and rebellions. Because of this, they just didn't have the resources to maintain those dikes. So when unprecedented rainfall hit, the deteriorated walls simply gave way. And the crazy thing is, the initial floodwaters were just the beginning. Secondary disasters, things like massive crop destruction, famine, cholera, and dysentery, actually killed far more people than the drowning itself.
Let's walk through this timeline to see exactly how a nightmare like this plays out. This is the sequence of the 1931 Yangtze River Basin floods, which is widely considered the deadliest natural disaster in recorded history, with up to 3.7 million people dead. It all began with incredibly heavy winter snow, which was followed by a rapid spring snowmelt that swelled the rivers. Then, an unbelievable 7 cyclones delivered extreme rainfall over the summer. By August, the weakened, unmaintained dikes could no longer hold back the pressure. When the Grand Canal dikes catastrophically failed near the city of Gaoyu, an estimated 10,000 sleeping residents drowned in a single night.
Let's look at Section 3, the warning and wealth gaps, poverty, inequity, and modern hazards. Moving into the modern era, we're going to look at how a lack of technology, combined with systemic inequities, are today's deadliest forces. But first, we really have to acknowledge the sheer terrifying power of nature. On the day after Christmas in 2004, a massive 9.1 magnitude earthquake ruptured the seafloor off the coast of Sumatra. To put that kind of magnitude into perspective, it released energy equivalent to 23,000 Hiroshima nuclear bombs. That violent, upward thrust of the ocean floor displaced an enormous column of water, triggering a completely deadly tsunami.
And this brilliantly illustrates the mechanics of a tsunami through a process called shoaling. Out in the open ocean, the wave is incredibly shallow. We're talking maybe a foot tall, but it is racing across the water at 500 miles per hour. That's the speed of a commercial jet. As it hits shallow coastal waters, friction from the ocean floor basically slams the brakes on the wave. With all that immense, fast-moving energy suddenly having nowhere to go but up, it compresses and grows vertically. It transforms a nearly invisible underwater ripple into a terrifying 100-foot wall of water when it makes landfall. But here is the profound tragedy of the warning gap. Scientists monitoring seismographs detected that massive earthquake almost immediately. However, unlike the Pacific Ocean, the Indian Ocean had absolutely no early warning system in place to broadcast that danger. Coastal communities in Thailand and Sri Lanka had up to 2 hours before the waves hit them. 2 hours! That is plenty of time to just walk to high ground. But because there was no alert network, they never knew what was coming, dooming over 227,000 people. We see this fatal intersection of poverty and infrastructure again during the 2010 Haiti earthquake. In Port-au-Prince, decades of rapid expansion happened without enforced building codes, so most structures were made of unreinforced concrete block. When the 7.0 magnitude earthquake hit, the lateral shaking easily shattered that brittle concrete. The structural supports completely failed, causing the floors to collapse straight down, directly onto one another. This terrifying process is called pancaking. It turned what could have been a survivable earthquake into a vertical trap, killing hundreds of thousands of people.
So the crucial point here is that this vulnerable infrastructure didn't just cause the initial casualties, it actively destroyed the rescue response itself. 60% of Haiti's hospitals were destroyed or severely damaged by pancaking. The government headquarters collapsed. Even the UN building collapsed. That structural vulnerability wiped out the exact medical facilities and leaders that were so desperately needed to save lives in the aftermath.
Which brings us to Section 4, Lessons Paid in Lives, What Disasters Reveal.
We've covered some truly immense historical tragedies today, but the overarching takeaway of this explainer is that societies can choose to learn from these catastrophic losses. Fortunately, we have seen real positive institutional changes in the wake of these events. After the devastation of the Bola cyclone, Bangladesh dramatically improved its warning systems and built a vast network of raised, concrete cyclone shelters. When massive cyclones struck decades later, the death tolls were just a fraction of what they were in 1970. Likewise, the global response to the 2004 tsunami funded the Indian Ocean Tsunami Warning System, which now uses advanced deep ocean dart buoys to detect pressure changes and broadcast warnings instantly. So we are actively building systems to prevent future surprises.
I want you to consider this profound reality. The earthquake did not create Haiti's vulnerability. It revealed it. This really serves as the thesis for everything we've explored today. Disasters are the tragic intersections of natural hazards colliding with human conditions. Nature might trigger the event, for sure, but it's the poverty, the crumbling infrastructure, and the social inequities that actually turn a hazard into a catastrophe. So I want to leave you with a provocative question to think about today. What is your community doing to reduce its vulnerability before the next hazard strikes? Are your building codes strong? Is your early warning system up to date? Because while the hazards of nature are absolutely inevitable, a disaster doesn't have to be. Thank you so much for joining me for this explainer. Keep learning, stay prepared, and I'll catch you next time.